Hello everyone, welcome back to my channel. Today I will discuss about the Karl Fischer titrator. The Karl Fischer is a widely used method for measuring trace amount of water contained in various substances, particularly the pharmaceutical industry and the petrochemicals, and it is named after the chemist Karl Fischer, who developed the technique in the 1930s. The Karl Fischer method is highly sensitive and this is specific for water determination, and it is widely used in the various industries where accurate measurement of water content is critical for quality control and product specification. However, it is important to note that the Karl Fischer method may not be suitable for samples that contain other substances that can interfere with the reaction, such as reducing agent or volatile solvent. And proper calibration and validation procedure should be followed to ensure accurate and reliable result. So, what is the mechanism? Now we can discuss about the mechanism of this Karl Fischer titrator. Basically, it works based on the chemical reaction between the water and iodine. Between the water and iodine, they have a various kind of titrant. Combi titrant. This is also called the combi titrant 2, combi titrant 5, etc. The principle behind this method is that water react with the iodine. Basically, the water which is contained in the sample, any sample, which react with the iodine. The principle behind the method is that water reacts with the iodine in the presence of a sulfur dioxide as a catalyst, forming iodine ions and the hydronium ions. This reaction takes place in a Karl Fischer titration cell, which typically contains a solution of iodine and the sulfur dioxide. And the solvent, we can use the methanol or ethanol. The sample being tested, which may contain trace amount of water, is introduced into the Karl Fischer titration cell, and the water in the sample react with the iodine to produce iodine ions and hydronium ions. The iodine ions react with the base in the solution, producing a titrable species, usually iodide ions. The amount of iodine required to complete the reaction is determined by monitoring the change in electrical conductivity or by using a potentiometric sensor. The water content in the sample is then calculated based on the volume of Karl Fischer reagent required to complete the reaction. So, the Karl Fischer titrator is very important to determination the water content in any sample. This is very sensitive. Here you can see the Karl Fischer titrator, and this is the chamber where titrate the sample. Here have a magnetic bar, and basically it works like a conical flux. You can see here, and this is the reagent, the Karl Fischer reagent, also called the Karl Fischer reagent here. This also combi titrant 2, combi titrant 5, etc. And this is the line between this and this one. We can use methanol, ethanol for solvent, and the ethanol and methanol must be water free for this titration. Now you can see how is work. So this is the working system. You can show here. Here is the solvent, titrate the solvent between the sample here. We inject sample here, and it works very sensitively, and finally determination of the water content of the sample. So this is about the Karl Fischer titration. If you have any question about Karl Fischer titrator, if you ask in the comment section. And thank you very much for watching this video. Stay with the research here. Thank you again.